All right. Yeah. So the whole story is, I guess we have time. We have time. We got time. I'll do this. I'm the last person. It's just me between you and a party. So I bought some marbles that had uranium on them that were used in a particle accelerator, and the company that sold them to me also sent a sample of uranium ore, and it was really funny because the box that arrived, like, it had warning labels all over it, like, this is radioactive. Anyway, I took it apart and I found the rock, and I thought it was kind of cool. There was instructions like, you have to wash your hands after you touching this because it'll burn you. So it's really safe. So I lost it and I couldn't find it, and I thought it was important to find, so I bought several Geiger counters in order to find it. And now I own like 3 Geiger counters, and I didn't find it until I moved. So the moral of the story is don't buy uranium. So my name is Aaron Patterson. You know me from the internet as Tender Love, and if I look strange to you in person, it's because this is my avatar online. So that's me online. This is me in real life. I have a couple of cats. This one is Gorbachev Puff Puff Thunderhorse. This is his full name, or Gorbachev Puff Puff Thunderhorse III. This one, her name is SeaTac Airport, Facebook, YouTube, Instagram, Snapchat. I don't know what the next social network is, but we just named her that because she has no idea what her name is. It doesn't even matter. So anyway, I have stickers of my cat, so come to me and say hello and I will give you a sticker of my cat. I also have some of the cards so you can enter the contest, so I want to get rid of all of those. But maybe he is familiar to you, maybe to some of you in the audience here, because I kept trying to airdrop him to people. And some of them denied me. I don't know who that is, Anton. It's trying to send my cat around, but anyway, I did get one response, which is this. So some people accepted it. Anyway, I'm on the Ruby core team. I'm also on the Rails core team. I work for a small startup company called GitHub. You may have heard of it. It is the first legit company I've ever worked for. I love Git, but I won't force push it on you. So a lot of people say that I use too many Git puns, but I really think it's time that I start branching out. Branching out. Okay, all right. Anyway, but if you don't like that one, go watch some of my other talks online. There are many other puns for you to get cherry pick from. Okay, all right. You're learning how bad my puns are. These puns are for me, not for you. They're for me. Anyway, we recently got acquired by another company. I don't know if you've heard of them. Another technology company. Anyway, people have always asked me, like, since you were acquired, has anything changed? And really the only thing that's changed is my background. Anyway, today this is actually really exciting. Today is the GPS rollover day. I guess technically it's actually tomorrow, but it's happening at 23:59:42 UTC. And what's really cool about this is, well, I guess it's cool. I think it's cool. GPS satellites actually only use 10 bits to represent the weekday. So every 1024 weeks, their clock rolls over. That's about every 20 years, and that's happening tonight. So tonight, their clock is going to roll over and actually be wrong. All GPS software has to take this into account. So there may be like weird GPS clock things happening tonight. So that's pretty exciting. I'm glad we can all share that tonight. I don't think I'm going to be up until 23:59 UTC. I believe that's like 3 in the morning here. So I will not do that. Anyway, there was one earlier this morning. You saw a presentation that posited that that double quoted strings are the same speed as single quoted strings. In fact, I can prove to you today that that is actually incorrect. It is completely incorrect. Single quoted strings are in fact 2 times faster than double quoted strings, and I will tell you the reason why, and you'll completely understand. Everyone here will agree with me. And the reason is that you have to hit the shift key to type double quotes. That's twice as many keys. So you can see clearly single quoted strings are much faster. But also we were talking a lot about logic today. And I just want to do a little bit of a refresher with you. We had a presentation about logic, and we all know this is an AND gate, or AND logic. We have OR logic. This is OR logic. You may be familiar with NOT logic. And there's actually a 4th gate that I don't know if you know about this one. This is business logic. Sorry. So I had this yesterday. Gammatogen. Am I saying all right? Gammatogen. Okay, so what I was thinking, what I really think is that somebody here needs to write some code. They need to write a gem, and they need to name it atogen. So that in your gem file you can do this. This is for someone out here. One of you, please take this idea. All right, so this talk is titled "The View is Clear from Here." Today we're going to be talking about both Ruby and Rails. Specifically, we're going to be looking at the view layer of Rails and how that works. And I have to give you a warning: in this talk, there will be code in this presentation. There will be Ruby code in this presentation. I'm going to talk about Ruby stuff, and I'm also going to talk about Rails stuff. And I also want to touch on some software engineering practices too, just some general software engineering practices, so that if you're not a Ruby or Rails developer, you can get something out of this talk. Hopefully we have some other folks, bringing some other folks into our Ruby community here. But Rails is an MVC framework, and for those of you that don't know, MVC stands for Model, View, and Controller. And if we set that paradigm up, it looks something like this, such that when a request comes in from the network, it comes in and it hits our controller. Request comes in, it hits the controller. The controller gets data from the view, or from the model. The model sends the data back to the controller sends the data to the view sends the rendered view back to the controller, and that sends that back to the request. So this is roughly how Rails is engineered, into a pattern kind of like this. And if we name those different components, they're named active record for the model area, the model layer, action controller is the controller layer, and action view is the view layer. Now, I usually work on and speak about active record. Like typically when I'm talking about Rails, I'll usually talk about that portion of Rails. Sometimes I'll talk about the controller, but I actually wanted to switch a little bit here and talk about the view layer. So this is the area that we're going to be talking about today, is the view layer in Rails. Specifically, we'll be talking about action view. And action view's responsibility has about three different responsibilities. First off, it's responsible for finding templates on your file system or wherever those templates live. It's responsible for compiling templates, and it's responsible for executing views. So it has to do generally these three things for us. So the way that we're going to talk more about finding templates in detail, but essentially action view will look for files on your file system and read those files in and compile them. So let's talk a little bit about the view templates. We're going to discuss ERB templates, but all the techniques and things that I'm going to talk about today apply with any templating system, so they apply just as much with Haml or whatever templating system you want to use, but I'm going to discuss ERB because it's default and that's what we use at work. ERB was designed or developed by someone named M. Secchi. He's on the Ruby core team as well. And if you have used it, hopefully you have used ERB. It looks something like this. This is what an ERB template looks like. And if you want to compile this view, you can just require ERB and use it like this. So we just require ERB and we say ERB new and read in the file. And we can actually print the source code for this template. All the ERB compiler does is read in the template and translate that template into Ruby code, and then we can evaluate that Ruby code and get a result from it. So if we print out the source code for this template and look at it, it'll look something like this. This is what the source code for that template will look like. Now, if we execute this code, it'll actually break because we don't have a render form function and there is no link to function. So those exist in Rails, but in our little example here, those functions do not exist. But you can see what the Ruby code looks like that template is turned into. So I mean, it might be kind of hard to read, but it's really just Ruby code. So if we modify our compile script just a little bit, we can define the render form function and the link to function. And now when we compile and execute this view, we can actually get some output from it. So it'll look like this. Just normal, as we'd expect. So we're going to talk about one strange and not fun challenge about ERB. We saw a couple tags in ERB. We have on the left, that's the ERB tag, and on the right is what it gets turned into in Ruby. So that top one there, we execute a function and output the result of that function. That second tag there, it just executes whatever Ruby code is in there that has no impact on the output. Now, what I want to look at here is capturing blocks. And this is probably something you've done in Rails. It seems fairly common. We have this capture do, and typically what it does in Rails is it captures the stuff in that block and prints it out. So here is how maybe we would implement this. Now, the question is, what is the output from this template going to be? What will it look like? Is it going to be, are we going to print out hello before the tag? Are we going to print it out in the middle like it should be? Or are we going to print out an error? So actually what happens is it's a syntax error. So, and the reason it's a syntax error is if we look at what the compiled Ruby looks like, we have this extra end here down at the bottom. So we did capture do 2s, and then we have some end there that's being dangled, and this is just not valid Ruby code, so we'll get an error when we run this. And if we look at the source of the ERB template, this translation makes sense. We told ERB that, hey, we want you to evaluate this top capture, but this bottom end is just arbitrary code that we want you to execute. So it just does, ERB is not smart about what Ruby code is inside of these tags. It just does exactly what you say, which is evaluate this and print it out, or just evaluate this. So ERB had no idea that this do and this end belong together, so it did not translate them correctly. So how does this work in Rails? In Rails, it is a, I'll tell you how it works in Rails. It works via a huge hack. Here is what the huge hack is. Basically what it has is it has this neat regular expression, and it scans your Ruby code with this regular expression looking for a do or looking for a curly brace or anything that looks like a block. If it thinks it's a block, then it'll do the right thing and output something that captures the results of that block. So I think we've gone down a little bit of a rabbit hole here, so I want to back out just a little bit. Just a little bit. We've gone down into the code too much. There's different flavors of ERB. There's three flavors that I know of. There's the original ERB that ships with Ruby. A newer one came along called ERBIS that was faster than ERB, and it worked exactly the same, and we used that in Rails for quite a long time. But more recently, another ERB flavor came out called eRuby, and it's even faster than eRubies, and that's the one that we use today in Rails. And if you use ERB today, you have no idea, and it doesn't matter to you. They all work exactly the same. You don't need to know which one of these backends you're using. You just get a faster templating language for free. So eRuby is the fastest, and that's the one that we're using on the back end in Rails today. So let's take a look at ERB performance. We were talking about ERB performance a little bit earlier, so I want to talk about improving ERB performance now. And this is not Rails specific, or again, not template language specific. We're just going to talk about ERB templates. ERB, this applies to all templating languages. So let's take a look at this example here. We have a naive implementation. All this does is compile and execute the template. So we're able to render the template, and when we render this template, if we put this inside of a benchmark, we can see we render the template at about 27,000 times per second. So this isn't bad, I guess, but I think we can improve it. And you'll notice that we always compile this template and evaluate the template, but the result of that compilation is always the same. So what we can do in this case is say, well, let's compile, or let's cache that output. Since it's always the same, we can just compile it once and cache that. So we'll change the implementation. So you don't read this too closely. I'm explaining it. I will say in words what this says in code. So all this does in the pink box is actually cache that template into a hash. So it compiles it and caches it. So the first time it's slower, but every other time it's faster. And if we run this in our benchmark, we can see that, in fact, this runs at about 63,000 times per second, which is much faster than our previous implementation. Now, we can improve this yet again. We're still calling eval on this template. We're still evaluating that Ruby code every single time. So we can improve this even more. What we can do is we can say, well, instead of calling eval, let's actually define a Ruby method. And inside that Ruby method, inside that method, we'll have the code for the ERB. The ERB template, the source of the template, will actually be the source of that method. And then instead of calling eval, we'll just call that method over and over again. So if we execute this benchmark, I know these numbers are hard to read, but it is 1.4 million times per second versus the 63 million times per second. So it's 52 times faster than our original implementation. So what we're doing here is we've gone from compiling and evaluating the ERB template every time to just turning it into a method and calling that method every time. And this is a zoomed in part. I knew this would be hard to read, so I made a zoomed in part of this method definition. All we're doing here is we're saying, hey, compile the ERB template, take the source of that template, and stick it into a method that we dynamically generate. So right here is our template source. Here we compile the source to that template. Here we generate a method name, and in this case we're just calling it render index in this example. And then the source of that method is the source of the template. And this is what that method will look like. So inside that method is the source of the template that we saw earlier, which is right. Then we just call send and render the method itself. So in Rails, all templates are translated into methods. And then we just call those methods. So since we know that these templates are translated into methods, that gives us a couple things that we can do. One, we can look at all the methods that are defined. So if you do this in a template, say puts all the methods and grep for app, you'll see these weird method names. And these weird methods are all the templates that have been compiled. Those are the method names of the templates that have been compiled. We can also measure how much memory each template takes. So we can say, okay, give me that method name, and then get the instruction sequences for that method, and then tell me the size of those instruction sequences. And this particular method is only, I guess, 1,200 bytes, where larger templates might take more. But you can actually measure them since we know the method names. So this is the template. This is the way template handling works in Rails. And up until this point, everything that we've done is just using Ruby's standard library. So from here, I want to talk a little bit more about Rails-specific behavior. Specifically, I want to talk about instance variable visibility. So say we have some template foo HTML, and we have another template bar HTML, and well, they're both able to access the same instance variable. So why is that? Why can they both access the same instance variable? If we think about the way that templates are compiled, it actually makes sense. We're compiling these two methods, or these two templates, into two methods, and these two methods live on the same class. And of course, all methods on the same class can access those instance variables. So they're able to access some instance variables because these methods live on a regular class. This is a plain old Ruby class like any other class. Now, there is one thing I have to say, which is don't use instance variables in your templates. And you can quote me on that. Don't use instance variables in your templates. And the reason I say that is because essentially these are global variables when it comes to your templates. If you're looking at this instance variable, you think, where did this instance variable get defined? Who defined this? Was this defined in a different template? Do I have to render another template before I render this template? Do I have to call? Does this only work with a certain action in a certain controller? There's too many questions about where this instance variable comes from. And we, at GitHub, we actually don't allow this at all. We use linters to prevent this from happening. So I don't like these, and I'm guessing other people have probably run into similar issues that I've described to you now. So we prefer to use local variables, and I'm going to talk about how we use local variables. So local variable looks like this. All we say is render some template, and we pass in some locals like this, right? Now, let's imagine that the template that we're rendering, this content template, it looks like this. Let's pretend that's the source of the template. It says hello name. Now, we all know how to compile templates. We looked at it earlier. Oh, I don't have a timer there. I got a timer here. Okay. We saw that earlier. And if we compile this using all the techniques that we used earlier, the output will be something like this. We'll have render content, and it's going to look for name, call name, and say .2s on that, and output all this stuff. But the problem is, this is a method call. If we look at this method, name.2s is a method call. It's not a local variable. There is no local with the name. So that's not what we want to have happen. We want it to define a local variable and assign it to that value. So how do we actually do that? And the way we do it is we define a preamble that defines all those locals. So for example, we have this template here on the left, content. What it will get compiled into is a method like this, where we have a preamble that says like name equals locals name, and I think the actual hash in Rails is like local variables or something like that. But we have a locals preamble like this, and that defines the local variable for your method. So this leads to a couple of different problems, though. So let's look at this HTML template here. We have this hello name, right? It's the same one we saw earlier. Now, if you look at this template, can any of you tell me, is this a local variable, name, or is that a method call? And the problem is you can't tell me. We don't know. We can only know via the context, the caller. We don't know if this is a method or a local variable. We have to actually look at the render call. And the annoying thing is that it actually depends on which one we have here. So in this first case here, we're saying locals name Gorby, and it's actually a local variable in this case. But in this second render call, it's a method call. So it means that, what this means is that we can't look at this template and compile this template in advance. Templates cannot be compiled in advance. And the reason they can't be compiled in advance is because we don't know which one of those are local variables and which one of those are method calls. And this is bad for servers like Unicorn, which we use at work. It would be more ideal if we could compile all these templates in advance and then fork children so that they all share the memory. But instead, all of the child processes actually have to compile the same templates over and over again. So it would be nice if we didn't have to do this. The other issue that this causes is that it means that these templates can be compiled too many times. So for example, we have here main.html.erb with 2 render calls to content, and both those 2 render calls are passing 2 different locals hashes. And what this means is that we're actually going to have to compile that template twice. Once with just the name local, and then once again with the name and the friend local. And even worse, so right here we have these unique preambles. They have to be unique so that we can define them. Now, what's really bad about this is we never even used the friend local over here, and yet we're getting another template compile. So you might be saying to yourself, Aaron, this is nice, but what should we do? This is fun and interesting information, but me as a Rails developer, what does this have to do with me? Well, right now, there's nothing that you personally can do about the pre-compilation issue that I talked about. We're actually working on a way, at work, we have a way for doing this pre-compilation. So we do this on github.com. And one of the things that my team does is take some of the stuff, or take the stuff that is not core to our business and try to upstream that into Rails and open source it. So we're actively working on solving this pre-compilation issue for everybody. But one thing that you can do today is always pass the same locals to individual templates. If you always make sure that that hash has the same keys, then you'll ensure that those templates are only ever compiled once, and you'll save memory there. So the next thing I want to look at is the render function. And at a very high level, the render function has these responsibilities. It finds a template, compiles a template, calculates a method name, and calls a method. So basically, the flow looks kind of like this. We find a template, possibly from cache. We ask, is it compiled? If it's not, we compile it, calculate a method name, and then call the method. If it is compiled, we just call the method. So sometimes we have to compile the method, and sometimes we have to figure out a method name, but not always. So we've seen most of the pieces of this puzzle, compiling and calling methods. Let's take a look at finding files. Now, to do this, I built a test application, and we have to know that template rendering depends on the requested format from whoever made the request. So based on that format, based on the accept headers from the incoming request, we decide which template to render. So let's say we have this controller here, users, and we have a couple of views. One is an HTML view, and the other one is an index view. So we'll look at the app user. These are the 2 templates that are possible to render. And the source of those templates, we have an XML template and we have an HTML template. So this is some kind of strange behavior, but if we say curl and we say give me the XML template, the response is the XML template. It renders the XML one. If we just say curl, it renders the HTML one. And if we say curl text HTML, it renders the HTML one. So this seems fine, okay? It's going to get a little bit stranger. But in order to know whether or not a template is compiled, we have to look at the format that's being requested. We have to look at these particular keys. We have to look at the local variables, which we saw earlier. We have to look at the format, the accept value, so we can look up the file. We also have to look at the locale. Maybe you have EN or JP templates, and maybe variants as well, like iPhones or different types of views, depending on what you want to see. Now, unfortunately, we can't know these things in advance. We have to wait until the accept header comes in. So this is another problem for pre-compilation. We have to wait until a request comes in before we can know what to compile, because we don't know how to look it up. And this actually leads to some very strange render behavior. So here's another example. We have the same user's controller, and in this case, 3 templates here, 1 index HTML and 2 partials, okay? A ping and an XML partial. I know it's kind of weird, but bear with me. The contents of these partials, we have the user's index. That just renders my template. And we have this one that's a ping. The source of that is just, I guess this is a ping. And this one is XML. XML is cool. It's really cool, right? It's cool again. It was cool, and then it's not cool, but I think we're back. Just kidding. Okay, so if we do a curl, here. For XML, we'll get an error. Makes sense. because we don't have an XML template. If we do a curl, it renders the user's HTML, and then it renders the ping as the subtemplate. So it renders those two. If we ask for text HTML, we actually get an error. It says it can't find a partial. And if we use the browser, we also get an error. So for some reason, curl is different than a browser. Just a blank curl is different than a browser. This is what the browser response looks like. It's an error, and this is what you would expect to see. I tried to render this. There is no HTML template. So the issue is that when you look at this template, we can't predict what template my template is going to be. So if we wanted to compile this in advance, we need to know, hey, what is this render call going to call? Where is this actually going to go? We can't tell this in advance. So if you use a respond to instead of just a blank render in your controller like this, format.html, we actually get consistent behavior from the controller. We'll get a missing XML template, and then all of these have a missing HTML partial. So we have a consistent behavior here. So if you think about this, it's kind of crazy the way that this is behaving. Why would it render a ping file when you're just doing a normal curl? So this call, the behavior of this call to render depends on how the controller rendered the template, whether it's a bare render or if it's inside. This call to render depends on whether it's a bare render up there or if it's actually inside of a format.html. And I think that this is very confusing. You can't look at this template here, this index.html template, and tell what the behavior of this method is going to be. You don't know. It depends on the caller. You have to go look at the caller. And to be honest, that's too much for me to keep in my head. I'm actually serious about that. I know it's only 2 files, but when you're working on a large application, how can you keep this in your head? So the issue here is that templates are not context-free. We can't look at a template in a context-free environment and understand what it will do. We can't predict consistently what the behavior will be. And I keep talking about these 2 topics, prediction and consistency, and I want to talk about why. So we had this flow before here where we find a template, compile it, and call a method. Now, if you benchmark view rendering, you'll find that asking whether or not a template is compiled is cheap, calling a method is cheap, but actually finding that template is very expensive. So looking that template up from cache is very expensive. So we have to know, like, well, if we knew in advance, like, hey, this render call is actually being compiled down to a unique method. So we knew previously that all of these templates are actually just compiled into methods. They're evaled into methods. If we knew in advance what that method would be, we could do some interesting things with our program. But unfortunately, we don't know that. So if we could predict what that method would be, then instead of, we could change our compiler such that instead of looking up that template every single time, we could just translate that into the method that we're going to call eventually. And if we were able to do that, we could actually eliminate this find a template part, because we could do that in advance. That would actually go away. And then, in fact, all of this would just go away. We wouldn't have to ask whether or not a template is compiled, or compile the template, or do any of these things. We would just end up with a method call at the bottom. These same steps would exist, but they would only happen once at the boot of your application. So, in fact, these things would only happen once, but only at the boot of your application, as my great transitions flow. So this would only happen once, and it actually translates into having slower boot time in production. But this boot time could actually be eliminated by boot snap. But the good news is that we would actually have lower memory because we're able to compile everything in the parent process, and then all of the child processes can share that data. But it actually turns into a faster runtime where we don't have to do this cache check penalty anymore. So I want to do kind of a detour here. This prediction technique is one that we use at GitHub, and we're going to upstream it. And we've been researching how to do it, but I ran into a strange issue while researching how to upstream these techniques. Let's say we have these 3 templates here. One is our collection. It renders a collection of customers. Okay, and this is the same template here, but we cache it. We say it's cached. Okay, so these two templates here are the same, except one is cached. And then this one is just our customer template. Okay, now this list of customers, there's 1,000 customers, and they're all just active record objects. Okay, in both cases. Now, can you guess which one of these two is slower? The cached one or the non-cached one? Which one of these is slower? I mean, the answer is actually pretty obvious. The cached one is slower. If the cached one was faster, I wouldn't make this slide. But the cached one is actually slower. I ran this benchmark. I couldn't believe it. I was looking through how this worked, and I ran a benchmark. I filed an issue. You can go look at the issue right here. Now, writing the benchmark is kind of complicated, so I didn't put it in the slides. You can go look at it on this URL. But when I ran the benchmark, I saw these numbers, and it turned out that the cached one was actually 5 times slower than the non-cached one. I couldn't believe that. Like right there, 5.6 times slower. I'm looking at these numbers, and I thought I was convinced that this cache did not work. How could it work and be 5 times slower? But then I look closer, and there were entries in the cache, and there were entries in the cache. It was querying the cache. So I profiled the code, and it turns out, like, you can't tell very well from this profile, but it turns out that actually calculating the cache key was more expensive than rendering the template. So if you make the template more and more complicated, eventually the template will reach the cost of the cache key, and then it'll actually pay off. And this is what it looked like. This is the payoff point. I found out if I filled up that template up to here, then the benchmark results came out to be approximately the same. So they're about the same right there. So what this means is that cache does not mean fast. All right? So what I personally want to do is I want to make rendering fast. I want to make rendering fast. And I think this is actually kind of funny, because I want to make rendering faster, and if I make rendering faster, that actually means that this caching system becomes less useful. Which I find amusing. But anyway, I want to make rendering usually fast, and I think that we have a couple of ways that we can do this. And I want to go with a way that has the smallest impact on Rails applications. So here we have an example. I want to make what I call the same format assumption, and what that means is that. I meant to do that. So what that means is that we say, okay, in this case, if we're rendering my template, since my template is inside of an HTML template, we should assume that that template is HTML. Now this second one, since we specified the format, it's specific. We know it's supposed to be a ping, so we know it'll go to the ping file. So this way we say, okay, we know for sure it is not ambiguous. This one renders a ping file. In this other case, it's inside of an HTML file, so we'll assume that it's going to render an HTML file. Now, in the case that we have an ambiguous render problem, so the case where we say render my template and we have a ping in an HTML, we know that from that HTML call, we'll be rendering the HTML template. So we know, as we saw earlier, we can't say that these two are exactly the same, because sometimes it renders an exception, sometimes it renders a ping. So this is the case where we're missing that HTML template. What do we do in that case? So I think what we can do in that case is say, well, you know what, there is no HTML template, so instead of just optimizing this particular case, we'll fall back to just calling the regular old render. And in this case, we can always, we know that this one is always an exception, so we'll raise an exception there because there is no HTML format. So this is as opposed to the always optimized case, where in the always optimized case, everything will just blow up. I don't think that's what we want necessarily. So in the always optimized case, we would have to know that this is a ping and the other one is an HTML. So I think if we use this same format assumption, this particular case means that we could optimize every single render call in your application, but I believe that this same format assumption will optimize most of your calls. I suspect this is what most applications have. So in this case, we'll actually optimize over to this, where we have 2 method calls just straight in your template. And in the case of the ambiguous template where we don't know what it's supposed to do, we'll end up with something like this, where we just raise in the case where we do know it's a raise, and in this other one we'll just say, okay, go ahead and render. Do what Rails normally did. So let's wrap this up. Today I presented something here that we do at GitHub, but because we don't have some of these rules in place in Rails, specifically this ambiguous render issue, we can't upstream this due to these corner cases. So if we can say that this particular assumption is okay, then we can actually take this code and upstream it, and we can have faster templates in general. So I want to end this with a few lessons, a few things that we can take away. The first lesson is be context-free with your code. If you can, make sure that your components can work in isolation. So that allows you to reason about that particular code in isolation. You don't need to know about other parts of your system in order to understand how this one part works. Be consistent in your coding as well. All of your functions should have exactly the same behavior, and this is basically the same thing as I said in the previous slide. But I want to be clear. It's that calling a function should always have the same behavior, no matter where it's being called. Otherwise, the system can be too hard to understand. Bench cache does not mean fast. Hopefully it will be faster. I think we can actually improve the performance of that caching system, but it's not necessarily true, and there's only one way that we can know whether or not caching is faster, and that's to do benchmarks first. So actually benchmark your code. That case that I showed earlier, like, it's not actually a real case. It's a micro benchmark. You need to actually benchmark your code and determine whether or not this caching system will be cheaper for you. And as a very practical thing, one thing you can do today in your Rails applications is make the locals match for each unique template. So not all locals have to be the same, just for that particular template. So I want to say thank you very much. It was really an honor to be here. I really appreciate having you all being here today. Thank you.
Thank you, Aaron.
Do we have questions time?
We have questions time.
Yes.
So?
You can ask me now or later, and I'll give you stickers later, or you can ask me now.
Hello. Aaron, I'm here.
Oh, yes.
Yeah. Thank you for your talk. What do you think of an approach when you always pass the only one local to every view, which is just a hash? And moreover, you pass the empty hash when there is no locals.
That's a very good question. Actually, I think that's actually great. So at work we actually pass view objects between all the templates, so they only ever get one parameter, and that one parameter is an object, but it could be a hash. I think it's a good idea. I just think that to be quite honest with you, I think that DHH would not accept that. But I like that idea.
Okay, thank you.
Hello.
Yes.
Thank you for your talk. Have you ever thought about possibility that uranium was eaten by one of your cats?
Yes.
And now it's got a superpower. Did you check?
So I did think about that. I was actually really worried. Like, what if the cats got a hold of this rock? When we moved, I found it. But it turns out that the uranium was inside of a cardboard box, and the sample was actually pretty weak. So the cardboard box was enough to block the radiation, so I couldn't detect it with my Geiger counter. Unfortunately, since we moved, I lost it again. So hopefully the cats haven't eaten it.
Any more questions? Okay, then you may approach Aaron later at the after party, say hello and get your sticker.
Yes, come say hi.
At your own risk.
I love taking selfies and talking about cats and coding. So please come say hello.
Yeah, thank you.
Thank you.